Good morning, good day, and good evening. I'm, as always, your host, Brody Robertson, and the way we do Linux audio has changed quite a bit over the years. Nowadays, we're doing a lot of things with Pipewire, and a core part of Pipewire is the session manager. And today, we have a person here who is very involved in that, who without this person here, we probably wouldn't have the one that we mainly use nowadays. So how about you introduce yourself and we'll just go from there.
All right. Hello. I'm George, and I'm a software engineer working on Pipewire and Wireplumber. I'm mainly known for Wireplumber. I wrote Wireplumber basically from that whole stack. Pipewire was written by Win, and yeah, that's uh, that's some basic intro about me, I guess.
Short and simple intro, I like it. Sometimes people go for like 5 minutes. I don't know when they're going to stop. I can't ask a question, but that works as well. I think we should probably start from. Uh, there's a few ways we can approach this. I think the best way to start is sort of explaining how Linux audio works, how Pipewire fits into the stack, and then we can move into the whole session manager stuff. So, yeah, I guess this could be an entire conversation just by itself, but how does audio work on Linux? Like, what is actually happening here?
Right. So at the lower level, you have um, ALSA, which is a component of the kernel. And this is the component that interacts with the sound hardware, the audio devices, and it exposes them to the user space, to the applications that are running on our session. Nowadays, with Pipewire, how this works is that Pipewire runs on top of that. So it's exactly the layer above ALSA. It grabs your ALSA devices, it opens them, configures them with the correct parameters, and then creates the appropriate objects that allow applications to basically connect to Pipewire and link to that sound card and get access to the sound card and either play audio or record audio from there. Um, so yeah, I don't know how much in detail we
You can
want to
go into
get
as much detail as you want to.
as a
I,
starting
I
point,
I
right?
understand that this topic is such a broad question that you could just spend the entire conversation just talking about this specific question.
Yeah, right, right. Um, so Pipewire is basically something that sits between your applications and the sound card, and it started from something else. Actually, it started from being a video device broker. Let's say it's something that was supposed to connect to your cameras and give access to applications to those cameras, right?
Yeah,
But
some people
then it
may know
evolved and
that
added.
originally there was the discussion of pulse video.
Exactly. Yeah, it started from Pulse Video. It was actually being called Pulse Video initially. Yeah, and then it got renamed twice until we reached Pipewire. Um, so that was the original idea, but it seemed like something more generic could be done out of it. And so we built the support for audio devices as well, and also other things. And I think it was modeled as a generic multimedia bus. That if you watch my talks, I often refer to it as a multimedia bus. It's not really an audio server. It's something that allows to transport media from one place to the other. And that these two places can also be two applications. So you can have application A, application B, and then these two link with each other and they transport media, either audio or video, from one point to the other. Or MIDI, right? It supports MIDI as well.
An example of this being what we're doing right now. I'm taking the audio from Discord, I'm sending it into OBS.
Exactly. Yeah. OBS is a great example of that. And you can take audio from Discord, send it to OBS. Also, OBS will be capturing capturing the video from your Wayland compositor, and then the Wayland compositor connects to Pipewire. It sends the video there, and then other applications can grab it.
Mhm.
So this is the generic mechanism. And then one of the, let's say, plugins there is the ALSA plugin, right? The support for accessing audio devices. And yeah, how this works is that it has a system there which detects your audio devices, and tries to make out the best representation of what's out there. Because like on the ALSA level, it's just a device handle which you can open with different parameters. It could be, you could set different rates, different channels. You can do crazy things, but it's not really something that's user friendly, right? So Pipewire sits in the middle and it tries to detect what's on your sound card using some configuration as well there. And yeah, then it basically creates those more user-friendly device objects that we see on let's say Pavu control. When you want to change your profiles and change your outputs, you normally use Pavu control or GNOME settings or KD audio settings or something like that. This is where you see the devices that Pipewire has detected, and you can change there. And that creates nodes, then the nodes can be linked to applications, and that's pretty much how it works. Now, if you go on the internet and look how audio on Linux works, you might get confused because people will say, oh, we have all of these frameworks, right? We have ALSA, we have Pulse Audio, we have Jack, we have Pipewire, we have GStreamer, we have VLC, we have, I don't know, a bunch of things.
If you're really old,
But
you might know Open Sound System.
Open Sound System, yes, of course.
Not really relevant today, but still part of that older
Yeah,
conversation.
it's not really relevant today exactly, and all of these are basically different components that sit at different levels. But if we're looking at the modern stack, what we use today, it's basically that. It's ALSA on the kernel level, then Pipewire sits on top, then applications which might be using GStreamer, might be using VLC, might be using some other library like FFmpeg or whatever, and they talk to Pipewire through that, and then Pipewire talks to ALSA. That's the whole stack nowadays.
So we also have you were saying about these plugins. So we have like the Pulse Audio plugin, the Jack plugin, the GStreamer plugin. So applications are expecting a certain API, and that's sort of why those plugins exist. It provides a way for those applications to interact with Pipewire through the language they already know.
Yeah. So for compatibility reasons, we support different APIs on Pipewire. Of course, Pipewire has its native API, but then we have also the Pulse Audio API and the Jack API. So all the applications that were previously talking to Pulse Audio through the Pulse Audio API can still work and function as they were before by just talking to the Pipewire server through the Pulse Audio API. And that Pulse Audio API is basically using a socket, a Unix domain socket, where all the original Pulse Audio library writes commands into that socket, and basically Pipewire sits on the other side and it listens to these commands, and it responds in the same way that Pulse Audio was previously responding. Same for Jack. No, Jack is a little bit different in how we have done the API emulation. We basically don't use the original Jack library, but we provide another library, which is the replacement Pipewire Jack API library. And applications, instead of like calling the original functions from the Jack library, they just link to a new library which provides the same functions, and they call those, and then this library translates the command directly into Pipewire native API calls. So So what happens there is the Jack applications actually use the native Pipewire socket to talk to Pipewire, just using the Jack API on their end to talk to the library.
I did not know that. Okay, we've already learned something today.
Yeah. And finally, we have also the ALSA compatibility. So some older applications want to talk to ALSA directly. So they just go to ALSA and they try to open a device and send audio there. And what we can do with the ALSA user space library, ALSA lib, it supports loading plugins. So basically, the application that talks to ALSA, it doesn't actually try to open the raw kernel device directly, but what it does, it asks the ALSA library to open the device. So the ALSA library then can load a plugin, and that plugin knows that Pipewire is running. So it uses, again, the native Pipewire API to talk to Pipewire. So it talks through the socket to Pipewire directly, and you get the audio like that way.
Right.
So again, it's going directly to Pipewire through the native Pipewire socket.
Okay. So
yeah, these are the three APIs we have. Yeah, go ahead.
Okay. So I guess there's probably a lot of ways to answer this, but why have we done this move from Pulse Audio as the main thing that applications interact with to this migration into Pipewire now that, it has this... I assume part of it is the fact that it has these plugins to interact with all these different APIs, but is it more to it than just that? Is it the fact that it also has this video capability, which is obviously relevant on the Wayland side? Do you have maybe some insight into why this shift has been happening basically across every distro? I think most have pretty much adopted it just by default now.
Yeah, well, the adoption is driven by where the community wants to go. And since Pulse Audio is being phased out, even by its maintainers, the maintainers are saying publicly that they support Pipewire now. So that means that Pulse Audio is going to be unmaintained in a couple of years. And obviously, we need to switch, right? So that's why people have been switching. But besides that, Pipewire is just a better implementation of the whole thing. And when I say better, I mean there's a couple of reasons, right? One reason is the latency. So with Pipewire, because it targets also the pro audio use cases and it targets also emulating the Jack API, it has been built with a very different architecture internally, which allows it to deliver audio with very, very low latency, even beating Jack in some cases, right? Some benchmarks. And that is something that Pulse Audio was never able to do. It will never be able to do. It has to do with the internal architecture, how things are handled internally. Yes. If we wanted to make it transport audio with low latency, we would have to rewrite it. But we have Pipewire now, so it doesn't make sense. Then I guess the other thing is that by having all those use cases built into Pipewire, by having Pulse Audio and Jack use cases built in, now we don't have to fiddle with the actual Jack audio server. So on default setups, desktop setups, you can run any application, even if it's a Pulse Audio application or a Jack application, and it will work. That's something that was really painful for users to set up in the past, where you would have to either remove Pulse Audio, like move it on the side and let Jack take over. And then if you wanted your browser to work, then you had to change your browser settings as well to talk to Jack. If you wanted other apps to work, like it was a frustrating thing to make it work. And we had setups where Pulse Audio would run as a client to Jack. Right. So applications would talk to Pulse Audio, and then Pulse Audio, instead of talking to ALSA, it would talk to Jack, and then Jack would talk to ALSA. So we were stacking things up.
Right.
And this is a setup that, it works, but it's not trivial to set up. people didn't have a great time like doing that, and it felt
Mm-hmm.
difficult. So one of the reasons is being user friendly as well.
Mm-hmm. So I guess this takes us into the discussion of Wireplumber. Then I'm sure we can keep talking about that side for quite a while, but my understanding is Pipewire doesn't by itself do any sort of internal routing, and that's sort of what the point of the session manager is, or at least one of the points of it.
Yeah, so Pipewire supports creating links between nodes, right? This is what the functionality of Pipewire is. Create nodes, which are the basic units of audio processing or video processing or whatever it is, and then create links between them, which allow the media to move from one side to the other.
Mm-hmm.
But Pipewire will not create those links automatically for anybody, right? So when an application connects, it just sits there. There's nothing linking it to your device or your other application, or whatever it is you want to do.
Mm-hmm.
Now, if we look back, Pulse Audio, it had built-in rules to do that. When you were connecting to Pulse Audio and you were asking to play audio to the default output, Pulse Audio would automatically link that application to the default output internally. And so you had this experience where the application connects and it suddenly is able to play. With Pipewire, that's not true. So if you're not running a session manager, connect to Pipewire, nothing happens. So there is a need to have something there that implements this logic of, okay, I have this new node here. What do I do with it?
Mm-hmm.
And that's why Wirepluber was created. And Wirepluber has, by default, it has the same logic as Pulse Audio. So that's how we started implementing things. We thought, okay, we want compatibility, so we have to basically bring the same user experience from Pulse Audio into Pipewire. So yeah, it does similar things. Like if a new application connects and it wants to play to the default output, then Wireplumber gets notified. It looks at that application node. It sends a command to configure it to the appropriate channel setup and sample rate setup and all of that. It has to be configured initially, and then it creates links to the device that it needs to go. That's the main thing that Wireplumber does. It's not the only thing though.
Okay.
So Wireplumber will also, first of all, manage the devices. So when Pipewire starts, again, it doesn't do anything. If you start Pipewire by itself, it's an empty graph. There's nothing. Somebody has to create the nodes for the devices. And that's where Wireplumber comes in again. So it will load the plugins that talk to devices like ALSA devices, Video for Linux devices, for your camera, Bluesy for Bluetooth devices, all of these things. Are you still there?
Yes. Can you not see me?
I think it's frozen.
Hello?
Hello?
Usually I'm the one with problems. Hello?
Hello? Yeah.
We
Are you
good
still
now?
there? Okay, Yes, it was frozen for a minute. I don't know where you cut off.
I'm usually the one with tech problems. This is new to me. Are we all...
I don't know. Is it my connection? Maybe
I
it
don't
could
know
be.
what happened. That's fine. So you're talking about how Wireplumber manages your devices.
Yeah. So I said about how Wireplumber basically is the one that links your applications to devices. But then Wireplumber also does more things. So one of the things it does is it manages your devices. When Pipewire starts, it doesn't do anything by default. It's an empty graph. And then if you need to, like, obviously you need to see that your device is there. So Wireplumber is the one that creates the instances of the plugins that will talk to the devices. Your ALSA device, your Video for Linux device for your camera, your Bluesy device for connecting to Bluetooth headsets. All of that is managed by Wireplumber. And then as soon as it gets notified about actual devices being there, it will create the appropriate nodes. It will select the appropriate profiles as well. Taking care of remembering your preferences. So when you change your profile for a card, that's something that Wireplumber handles, and it also Wireplumber saves the state and restores it afterwards.
So restoring things like the volume level? Is that
Volume level, yeah. Volume level, both for the device and the applications. This is something that Wireplumber manages. Restoring profiles, restoring like channel setups as well, and things like that. Another thing that it will also do is manage which one is the default device when you select it on your preferences. That's something that Wireplumber will also remember. And it will also select one appropriate choice when you first start up, when you don't have any other default saved on your state files. So it will select one default and it will manage. It will always keep one default device so that the policy always works. When you start an application, it will link to the default device. And something else that it's supposed to do is manage application permissions. So that's something new as well coming from Pulse Audio. In Pulse Audio, we didn't have access controls at all for applications. So basically, every application that would connect to Pulse Audio was able to change anything on any device, on any other application. It was able to do anything. And if it had a malicious intent, well, tough luck.
Right, so
you
any
couldn't do
application
anything.
could just listen in on the audio and it just nothing could stop
Yeah.
it.
Yeah, it could listen, it could also change volumes, it could do crazy things like
I see. Yeah.
yeah.
So like you could just suddenly throw it to 200% volume and that's not pleasant.
Yeah, and then blast your speakers or something, yeah. So in Pipewire, we have access controls built in by default. And that means that every client that connects, every application that connects has its own set of permissions for each object that lives in the graph. So every other node, every device, every link, every port, all of them have permissions, read, write, and execute methods. So when your client connects, Wireplumber has the ability to basically say, okay, what is this client? Is it allowed to access this and this and that, and apply the permissions. Now, at the time of speaking, this is not fully deployed yet, right? So we still don't really apply permissions. We let applications do whatever they want. We apply full permissions, but this is something in the works. We're working on it. We want to have a framework where the support layer is there. What we're missing is the Wireplumber policy, basically, to manage those permissions. And we want to have a system where we can say that, this application is, let's say it's a music player, it's a playback application, so it should have access to the audio output by default, but probably not access your cameras or not access your microphones or things like that, so that it cannot really do something unintentionally and change your setup there. Or if it's an application that you've installed from an untrusted source and you probably are using Flatpak or something similar to restrict it, then we apply even further restrictions unless the user chooses to lift them, right? So that's the idea. That's where we want to go with that.
I can see how early ideas might miss some like weird use cases. Like a example that I have is something I actually do. I route the audio from my capture card to my speakers, and that's a relatively normal thing to do. But I do know there's some people that have some weird audio setups that, because there's no permission controls on anything, technically work. So I do
Yeah.
expect that once that is like properly rolled out, there's gonna be some regressions that appear that aren't intentional, but are use cases that weren't entirely clear because, people do weird things when they're allowed to do weird things.
Yeah, I understand what you're saying. Um, it's true that people have weird setups and they do crazy things with their setups. And we constantly get reports about things that people want to do that are not
Good ideas.
like no, they're good ideas, but they kind of clash with policies that we have set up. And so sometimes we roll out a new policy and people are just confused. They're like, oh, this is a bug, that doesn't behave as it
Right.
should. Recent example, we had somebody contributed a module that when you're playing music to your headphones and then you unplug your headphones, either physical or Bluetooth, and then I think the main idea was for Bluetooth. So let's say you have your Bluetooth headphones, you're playing music, and you take them off, you unplug them, you turn them off, and that module basically goes by default and pauses your player so that it doesn't blast out of the speakers.
Yeah, this is a pretty normal thing that phones do.
That's a pretty normal thing phones do, yeah. I know also other operating systems do it. Like I use macOS as well. I know macOS does it that way. And it makes sense for a lot of users. But yeah, when we rolled it out, there are some people that were saying, oh, what's going on? When I unplug my speakers, it pauses my player. This is a bug. And they started reporting bugs to the player initially. Like it was the player's fault initially. But no, this is a normal thing. This is a policy that we rolled out. Same thing happens with people that use, speakers on the on their monitors. So they have an HDMI connection. They have speakers on the monitor. They want the audio to go there by default. And there are other people who have an HDMI monitor that has speakers, but they absolutely don't want audio to go there. So there's
I use
different.
Wireplumber to literally disable that node. I do not want to see it.
Yeah, so you are on that group, and there's the other group that they want that route to be always the used. So they expect when you plug a monitor, they want the audio to go there, and there is no good solution. We offer options basically, but there's no good default that we can say it satisfies everybody. So yeah, that's my point there being that unfortunately, Wireplumber is. Well, it's a policy tool, right? So we have to make up good defaults for a lot of people, but it won't be good defaults for everyone. And the only thing we can do is provide options, and we try to provide options where it makes sense so that people have a way to easily switch or change. Yeah. So I hope that this won't disrupt your setup, but I'm pretty sure we can find a way to add options to make sure that it doesn't break completely what you're doing.
Well, mine's pretty normal. It's not that crazy. It's just taking audio from a device and then sending it to a speaker. So that should, that seems pretty normal to me.
Yeah, I think it should work. And I don't think we are going to get very invasive with permissions initially. Permissions are generally more useful for untrusted setups. So I think we would be more enforcing more restrictions on Flatpak apps, which are
Right.
by default not trusted. But then for native apps, we would probably give more permissions, something like that. I think that would be a good default. But yeah, then we would have options also for devices that we work with. So that's one of the main things that I do at Collabora is we help customers build devices using that software.
Mhm.
And of course, there we have other levels of restrictions that we want to apply. We have other kinds of policies that we want to apply. And all of that has been built with that in mind as well. So it wasn't built exclusively for desktop users. It wasn't built with that in mind. It was built with how do we take that and make sure that the device works correctly. And on that context, yeah, we will want to apply more restrictions and also, do more crazy things, let's say, that desktop people will not see by default.
Yeah, I'm kind of interested about that because I know that in the past you have talked about Pipewire and automotive grade Linux. So,
Right.
what sort of requirements exist that don't exist in the desktop space?
Right. Yeah. So in automotive, if mm, yeah, if you how do I start from that?
Well, I guess
Basically,
for as like a
in
start, just explain what automotive grade Linux is, and then we can sort of go from there.
all right, yeah, that's easier. So automotive grade Linux is a project that aims to bring automotive companies together to collaborate on common software that they use. It's clear that automotive is going to the so-called software-defined vehicles, where basically the hardware, the engine is pretty standard. Is nowadays it's just a motor and a battery. Like there is nothing, there is nothing there. All of the complex engineering that was being done for internal combustion engines is gone. So what's left, and what is the value that they bring to people? And it's mostly the software, right? And we have from basic infotainment software, which has been there for a long time, actually. Things that things like playing music or playing video on your car, to very complex use cases like autopilot, like taking control of your car and doing all sorts of crazy things there. And all of the things in the middle, like there's a lot of lots of crazy use cases there when it comes to software. So automotive companies are moving to software, and in order to do that, they need to have they need to start from somewhere. They obviously use a lot of Linux on it, or they want to use Linux. There is also other operating systems they use that are targeted to automotive specifically. But yeah, Linux makes a lot of sense. So they try to make a platform based on Linux. And automotive grade Linux is an effort still to bring all of those manufacturers together so that they can collaborate and they don't have to reinvent the wheel every time they want to build a platform. So they maintain a base distribution, a Linux distribution based on Yocto. For those of you that don't know, Yocto is an embedded Linux distribution. It's a distribution that it's basically something like Gentoo Linux. It has a set of recipes that build the software. It's not pre-made packages. And it's targeting embedded devices. So automotive grade Linux is a distribution that builds on top of that, and it provides basic software and configurations that make sense in a vehicle. And yeah, there are some companies, the automotive companies, that build their platforms based on that. They take that as a base and they build on top. Now, if you go to a trade show or a conference and you see automotive grade Linux demos, you will see that there is a user interface as well. where you can play with things and play music and see your rev your engine revs moving and things like that. Like this is a UI that is supposed to be a demo. It's not something that you can actually install in your car. It's supposed to be the thing that people will see and test with when they build an automotive grade Linux. But then as the actual companies who are building the car take the software, they remove that and they bring in their own UI and user experience.
So where we were going with this was we're talking about like Pipewire in this space. So what requirements differ when we're talking about this space? Like what are people looking for that may be different from the desktop?
Right. So a typical desktop has 2 speakers and a microphone, right? That's the main setup. Now in a car, you can have a lot of speakers, crazy setups, and a lot of microphones as well. Crazy numbers of microphones in all places. And there can be very, very simple use cases, like you play a music file or a stream or radio, and it plays all over your car to all the speakers. So that's nothing. That's very easy. That's basically a desktop use case. But there could be cases where you separate the car in zones. So you have something playing over here, something playing over there. You take input from the microphones and you do crazy amounts of noise cancellation and a voice isolation. So you can speak. You're on the driver's seat. You speak. You're talking on the phone, and it's only you that can hear what's going on and speak to the phone. Like there are these kind of setups in very high end luxury cars where. Oh, I think I think I lost you again. Damn. Hello.
Hello, I can hear you. Oh, Discord. What a great platform this is. Okay. Discord problems. We're on Jitsi now. So yeah, let's just keep going.
Great. So I was saying about, that the car has a lot of speakers and a lot of microphones, and there are use cases, for example, where you isolate one person and you direct the audio towards one person, and you grab the voice from that one person, and you do crazy amounts of noise cancellation to make sure that nobody else can hear what you're saying on your call, and things like that. Now, of course, we don't do all of that in software in automotive grade Linux. What we do is this is a crazy use case that very few manufacturers do, and they do a lot of hardware there as well still today, with their intention being to move the software down the road. But what we do is we have we basically have policies to differentiate between streams based on the use case of the stream. So there are streams, audio streams that are basically music or media that you're playing, and then there is another audio stream that it can be your voice assistant, navigation assistant, right? And then maybe there's another stream where you're in a call and you receive audio from that call and you're speaking on the phone. So these kind of streams need to be handled differently. If we were applying the default desktop setup, desktop policy, we would basically be routing all of them the same way, just as we do on desktop. So if you start a call on your desktop with Jitsi, Discord, whatever it is, that doesn't stop your music. That doesn't change anything on your volume levels. It doesn't do anything in particular that recognizes the fact that you're in a call now. But in a car, there is a different policy being applied. So if you are in a call, then all your music will stop, and we will make sure that even if the application misbehaves, it won't be audible. It will be just isolated and won't go to the device. Same way for navigation assistants or voice assistants. There's another policy there that will say, okay, when the voice assistant is speaking, then if there is a music at the same time audible, we lower the volume of the music so that we can hear what the assistant is saying. These are also common things that happen on mobile phones. So the policy is not very different from what you have on your Android or iOS device. It's basically similar stuff, and there are also volume controls for each use case. So there's a volume control for multimedia, volume control for voice, volume control for calls, which is again same thing as it happens on mobile phones. So that's the main thing that is different today in automotive grade Linux versus the desktop.
So in some ways, you're less concerned about the individual audio devices and you're more concerned about the audio contexts.
Exactly, yeah. Yeah. This is something that could also make sense on the desktop. And actually, on our last update on this functionality, we added support for being able to run this kind of policy in parallel with everything else on your desktop. So if you want to try it on your desktop, it's there. You can enable it and you can configure your streams to have a context. And then this policy will be applied, right? And some people use it. Some people want to have a voice assistant, for example, and they want to prioritize it and duck the music. That's a common case that people ask for. And it works also on the desktop. The problem with the desktop, though, is that not all the applications will provide context of what they are, what they do. Especially web browsers are very tricky to get, to get the context, because a web browser can be playing music, it can be playing advertisements, it can be playing a video, it can be playing a call like we are doing now on TT. So you don't have that context, and there is no browser API to let the website give us that kind of context. So yeah, there is no way to know, and basically that's why that can't really be the default on the desktop. We don't have enough context.
Right. Okay, that makes sense. And especially as, you know, a lot of applications move into the browser and you realistically could do a lot of your computing just in a browser without some sort of extension to web APIs, which could possibly have some value, you can't really do much with that.
Yeah, currently we don't have the APIs, right? So there is no way we can do something. And there are websites also that might have different streams from different use cases that go out as one stream on Pipewire.
Right, like an ad playing and then the actual content on the page that you want to see.
Exactly, yeah. They can be the same stream as far as Pipewire is concerned. The browser can do mixing and it can do things. It depends on the browser, of course, and it depends on how the web API is being used. But yeah, there are these kind of use cases, and there is no way you can tell what it is and isolate different streams and do anything meaningful with that.
So one thing, with kind of jumping back a little bit, one thing we didn't really talk about. So we talked about how Wireplumber does this linking, but what didn't come up is that even though it is doing that linking, it doesn't prevent the user from doing additional manual linking themselves. Like as I was saying before with the taking the capture card audio and then sending it to my speakers. And you can do this, there's like a CLI tool to do this, but a much better way to visualize this is through a tool like QPW Graph. And I think even if you don't mess around with it, I think it's worth opening it just to see what is actually happening in the background and how things are actually being linked together. I think there's some value in sort of understanding what Pipewire is doing, and as you like open new audio sources and just see how much complexity there is that you don't generally have to think about.
Yeah, indeed. And that's one of the great things of Pipewire, is that you can visualize all that information in a graph tool, and change things, make your own links. It's really powerful. You can do crazy things, crazy setups, especially as you bring on Jack applications, which expect this to be there, right? So Jack traditionally had those tools for decades before it became a thing on Pipewire. And that's where the inspiration is coming from, right? And of course, yeah, Pipewire gives you the freedom to do anything you want. And Wireplumber won't stop you from doing that. But at the same time, there can be cases where if you don't understand what you're doing, you might be breaking things. That Wireplumber is trying to do one thing and then you are trying to do something else with your links, and that might conflict and you might see weird things going on. But I think those are more rare cases, as generally people understand what they're doing when they open these tools and they don't mess it too much. I hope.
Hopefully. No, I've definitely put myself in a situation where I didn't exactly have a good way to recover from it. But at the end of the day, if something does go really badly, just, kill off Pipewire, restart it, it'll fix everything. Probably.
Yeah. Something that Wireplumber doesn't do today, and it's on the back of my head on my to-do list, is to track what you're doing on the graph tool, right? So if you're, let's say, if Wireplumber creates a link and then you go and destroy it in the graph tool, Wireplumber doesn't know that you've done that. It doesn't track that you've destroyed the link. So it still thinks that the application is linked, and then if you're expecting it to do something, like if you completely unlink it and then you expect Wireplumber to recreate the links, for example, it won't do it because it thinks the application is still linked. Similarly, if you go and create different links of that application to somewhere else, again, it doesn't know that you've done that.
Right.
So this can be the cause of trouble if you this is why you can end up in a setup that doesn't work. And yeah, it's something that would be nice to have at some point, to be able to track those links and be and have an understanding of what the user is doing, so that when things start to break, you can take actions on Wireplumber's side.
That actually makes a lot of sense. I didn't know that, but that explains exactly why I have to open up QPW graph every time that I want to get the audio from my capture card to my speakers. I guess it's QPW graph is just loading the profile that it itself has saved so that it can return me to the state that I wanted things to be in.
Yeah, QPW graph also has the functionality of saving the links and restoring the links. In essence, it's another session manager that works alongside Wireplumber in this case and creates its own links. Speaking of, it's generally possible to have multiple session managers running at the same time.
Okay.
That's not something that Pipewire will prevent you from doing. So you could have even Jack session managers, traditional Jack session managers that save and restore states to be running alongside Wireplumber, as long as you are careful enough not to have them interfere with each other. So if you, as I'm saying, Wireplumber doesn't track what you're changing on the other side. So if your Jack session manager or QPW graph or whatever it is changing the links that were created by Wireplumber, then Wireplumber doesn't know, and it can get in a state where it doesn't work as expected. But if you are isolating those in your mind, at least, so you're creating the Jack links with the Jack tool and let Wireplumber do whatever else is there. It's doable. It's possible. It works, and it's also the recommended way. It's the way that we recommend people to work with Jack applications, because Jack applications are not being handled by Wireplumber because there is no single policy that can apply to them, right? There are nodes with wide number of ports that do all sorts of crazy things, and there is no way that we can understand how these are supposed to be linked, right? It depends on the application, it depends on what you want to do. So the recommended way is there to use a Jack session manager or QPW graph or a tool like that, and create the links that you want, save the state, and then have the tool restore it.
Now I understand why you said that QPW graph is kind of like a session manager. If you are using it, because I guess that is kind of how I've used it in many contexts, where I will open up a Jack client from the OBS side and then connect all the audio like that. I know the Jack tools exist, but I'm using QPW graph for other stuff anyway, so for me it just makes sense to do all of it with this one tool. Yeah, that makes sense, especially with usually when you're dealing with Jack applications, you're dealing with professional audio. So there's usually going to be a very specific setup that users want from that, and trying to assume what that's going to be, you're just not really going to ever be able to get yourself to work out what every random professional audio setup's just it's a waste of time trying to work that out, right? I think is pretty much the point you're trying to get there.
Yeah. I mean, you can do all sorts of crazy things, right? And it makes sense to, I think people are sensible in how they use these tools.
If you're using Jack, I think you know why you're using Jack.
Exactly. Yeah. You're using Jack probably because, you have a reason, you have a specific use case that cannot be done in any other way. So that's what Jack brings to you, to the setup. And yeah, of course, we're saying Jack, but we don't mean actually running the Jack server. You can do all of that on Pipewire. But we mean Jack applications and Jack APIs, and basically treating Pipewire as if it is a Jack server.
So Wireplumber is what everyone has basically adopted now, but there was another main session manager everyone was using previously that has now been deprecated, that being Pipewire Media Session. So what was different about that, and why does Wireplumber exist, I guess is the simplest way to put it.
That's a great question. Yeah. So Wireplumber started back in 2018, I think it was, where we were focusing on automotive with use cases. We started as a session manager for automotive grade Linux initially, because at the time automotive grade Linux was using ALSA. Basically, it wasn't using Pulse Audio even. It was a custom setup on top of ALSA. I was doing crazy things that didn't fully work, and I brought in Pipewire and I said, okay, this is the audio server that we're going to be using in the future. Everybody is going to adopt that. This is the new thing, and we decided to adopt Pipewire in AGL. But the problem was that there was no session manager. It wasn't creating links, and we needed some tool for that. So Wireplumber was born out of that use case. And at the time, Pipewire was still in the 0.2 version. It was like before it was popular, and there were a couple of things being done differently there, and we had to come up with structures to make all of that work. And we spent a lot of time on that, and we spent time also creating the tooling for AGL, make sure we have everything. Now, as we focused on the AGL, because we had quite hard deadlines as well, we had only a few months to come up with something. We didn't pay attention to the desktop. So we didn't create desktop policies. We didn't touch any of the Pulse Audio-like functionality. And we didn't even think about it. So the initial version was not designed to be able to be expanded to Pulse Audio-like functionality, right? It was very difficult to do that. And so, and I guess it was 1 year later or so, we started looking into that, and we had to rewrite a lot of things. And that was taking a long time, and the Fedora people were eager to get Pipewire out the door on Fedora. And they were kind of pushing Wim, I guess, to come up with a solution to have something, because Wireplumber wasn't ready, even though it was seemingly the best approach for the future, like, because we were building Wireplumber in a way that's modular. And also we wanted to integrate scripting. We wanted to integrate all of these features that would make it a good end user tool. But we didn't have any of that. So Wim started writing the Pipewire media session, which was a very simple version of all of that, all written in C, with hard-coded policies, with no settings. It was basically trying to do whatever Pulse Audio was doing, hard-coded. No possibility of changing anything. Just make sure that the basics work. No customization whatsoever. And it was clear from the beginning, right? This tool was created just to be able to support the transition from Pulse Audio to Pipewire.
It was to get something there so it could be done.
Yeah, exactly. Just to be able to support that and work for the initial transition, so that people could also test it, because Pipewire was not something that people could use, because they had to understand how to create links themselves, right? So it wasn't a tool that was actually usable, even among developers. Like, developers wouldn't know how to do that, so you had to teach them. And we didn't have the graph tools as well, that the UI tools that we have today. So you had to do it on the command line, and the command line is tricky, right? Basically, it was a tool to get things done. But we knew from the beginning that this was not going to continue for a long time. And we started porting Wireplumber to a new architecture at some point that was able to accommodate all of this desktop policy. And at some point, when we had something ready, we started showing to people how they can transition from Pipewire media session to Wireplumber and how to run that. And our initial goal was to be on par when it comes to functionality, have exactly the same functionality. But then we surpassed that. We have more functionality today, and yeah, as it became stable and usable and had more functionality, we decided to deprecate Pipewire media session. It's as simple as that.
Okay, so it was basically just needed to be there so that the transition could be done, that people could test it, and I guess with Fedora kind of pushing for it, if I remember my history correctly, that probably would have been not long before there was like a lot of work done to get video capture done on Wayland, and there wasn't really a generic way to do that before. So I guess that probably aligns with that. They saw Pipewire was gonna be a thing that could do this, because before GNOME was doing their own thing and WL Roots had their own thing and KDE had their own thing, and that was never gonna be viable for an application like OBS. You could never really build a generic screen capture tool like that, because everyone would just have their own different thing. I want to say 2020 is when OBS got screen capture support on Wayland, something like that. Maybe 2021. I know it was around that era though.
Yeah, I don't remember myself when exactly was that. But yeah, it was all driven by the Fedora developers, and they wanted a solution to allow basically, screen capturing, but also passing through that video to Flatpak applications. And there was a lot of development around that. And basically, as I said earlier, much earlier, Pipewire was initially created for that. It was created for passing video around. from cameras to applications, but then it was clear that this could also do screencasting. So all of that was developed. And Pipewire Media Session was also a way to get that actually working, to have something create the links for you so that it works. And yeah, it's been supported like that since then, even in Wireplumber.
So, I guess we haven't really talked much about configuration you can do to Wireplumber. Now, I did make a video, and I probably should change the title now, because I made a video on this prior to the format change. So that video is entirely outdated now, and everything in it is wrong. So originally, the format was a Lua configuration file, is that correct?
Correct, yeah.
So why did it change?
Right. So I guess I need to take this from the top and start with why Lua in the first place.
Okay.
Like how did we end up with Lua? In the initial stages of Wireplumber, we were writing all things in C, just like Pipewire Media Session, and we didn't have a lot of configuration. And at some point, we understood we needed, some level of configuration, people to be able to change things. The thing is, around that time we had a Hackfest. I remember we had a Hackfest. I don't exactly remember where it was, but I remember it was we were sitting down at a table with Wim and others, and one of the guys there, Bastian, he had come up with this idea to use Lua for configuration. At the time, I didn't know Lua. I didn't understand it as much. Like I knew it as I knew it existed. That was all I knew basically, and that it was used in some old games as a scripting language.
Right.
That's pretty much my knowledge about Lua. That was my knowledge about Lua at the time. So this guy brought the idea in, and he said he tried to convince us that this is something that is easily embeddable in a software that can also go into a device, but also it is very easy to write. It has all those very simple data structures that you can write scripts with, and it can basically support the configuration system with a scripting language, which would allow for more flexibility in the future. At the time, I didn't know Lua, as I said, so I didn't go for it immediately. We were in a rush to get things done for AGL, and so we invented a TOML-based configuration file, TOML file. We brought in a libtoml something. It was a library, C++ library that we were using to parse that and write that. And we implemented that, but of course it was very, very limited. We have only a few options, and it was pretty much constrained to the default policy. And after we had fixed that for AGL and the deadline was out of the way and we had everything working there, we started looking into Lua. And there were two things in Lua. Like, it was initially suggested as a configuration format so that you can create a script that basically configures how you want things to be done in your graph and toggle some options and things like that. But it was evident that it was also a scripting format where we could write logic, real logic, actually policy logic there. Without thinking too much about it, we adopted it for both. Like we wrote a scripting engine, and then I said, okay, let's use that also for the configuration. So we had one engine basically that was supporting everything. And note that at the time, Pipewire didn't have a configuration file. So Pipewire was not configurable.
Mhm.
We didn't have anything. No, actually, it had a configuration file, but it was a very, very minimal configuration file with a custom parser that was each line, it was parsed separately. It was like a INI format
Right. Okay.
configuration file, something like that. It was a very simple thing just to configure which modules you want to load and things like that. That was not something we could take on in Wireplumber. It wasn't giving us enough options. So we thought, okay, what else do we have? We can continue using Toml, or we can go into Lua, which gives us more flexibility, or we can pull in another library that does something else, like JSON, for example, or something else. But I didn't like the idea of bringing in more dependencies. So I had Lua there, so we used that. And so it was built like that, and we had the scripting engine, which allows you to build the scripts that have the actual linking logic. And we had the configuration files that were toggling options, basically toggling settings and deciding which modules to load and things like that, also in Lua. Now, that didn't work very well because people didn't fully understand how to use that as a configuration file. And they were also very, very confused about, yeah, very confused because, there was the scripting in Lua, there was the configuration in Lua. They couldn't understand what's the difference between those two and where does the Lua file go, because if you put it there, it's a script. If you put it there, it's a config file. And they didn't understand also how to override things, because you had to think as a programmer. You had to think as if all the Lua files are being concatenated together, and then there is a parser that goes through every line and runs the program. That's how it was working. People didn't grasp that, so they were basically copying the Lua files from one place to the other. We were shipping them in user share as data files, and they were copying that in their home directory, and they were changing things there without overriding, and overriding was hard. And that led to a lot of problems, because as we were changing the default configuration, for example, to load new modules that we implemented, people who had copied their files didn't get the new modules, and then their Wireplumber was crashing because it was expecting things to be there and it wasn't there. It was a mess.
Yep.
It was a mess.
I was right there with it crashing. There was an update that shipped, I don't know, 3 years ago, whatever it was, and then all of a sudden I would plug in a device and then Wireplumber exploded. And I couldn't work out why. I just ended up taking the folder, renaming the folder to something that's not going to be loaded, and then I'm going to deal with it later.
Yeah. Yeah, exactly. That wasn't clear to the users. It was hard. So in the meantime, Pipewire developed this JSON-like configuration format that we have today, which is, well, it's not standard JSON. It's a more simple version of JSON, but it can be parsed as a JSON. And you can provide also JSON files if they will be parsed by the same parser. So it's something that also allows people who want to develop tools for creating those configuration files. This can work with a standard JSON library. And that seemed like a very, very good idea. So you have a file that people can easily edit, but it can also be generated by machine code. And it was more easy to implement overrides. And as Pipewire implemented that and people started using that, they started becoming familiar with that. It was a great way to do configuration and overrides. And basically, I thought at some point, yeah, let's get over with the Lua config files. Let's use that. It makes sense. People already know how to use it. It has clear advantages to doing configuration. And then I did that. And of course, that also confused people, because now people were like, oh, but I thought we were done with Lua, but you still have Lua in there, right? But yeah, I kept the Lua scripting. That didn't go anywhere, but we changed the configuration file. They were two entirely separate things.
Yeah. Um, I do want when that update dropped. When the update dropped that went from Lua to, I guess, Spa JSON. Did what was did you get reports of things breaking? Basically, did you get reports of people saying their entire Wireplumber configurations just don't work anymore?
Yeah, of course. People always complain, right? When something breaks, they will come back and say, "Oh, you broke my setup." And of course, yeah, we broke a lot of setups, and yeah, people were confused.
Right.
They were expecting some migration tool to migrate their configuration, but that would have been really hard to write actually, because everything changed in the configuration. Like the entire way of loading modules changed. The entire way of this, like all the settings changed. It was impossible to go back and do a migration or anything like that.
Right. How do you
So yeah,
migrate a Turing complete programming language to JSON? Like you
yeah, exactly. It's not something that can be done 100%. You can approximate it. You can go and start part, like you can execute the Lua part and then see what it ends up with in options, and then try to maybe migrate some of the options. But it's not something that will be 100% correct, because
right.
if you had added any if else structures there that depend on something else, that wouldn't work. And also, not all of the options were one-to-one migratable, right? So yeah, we broke a lot of setups. Some people complained. Some people were like cheering because now it was much easier for them to configure things. And yeah, that's how it went.
Yeah, having a complete programming language there as a configuration language is it can work, but you have to be very careful with it. There are projects that are built around it, and then there are projects which I think would do better if they didn't. I always think of the awesome WM window manager. It also uses a Lua scripting language, and it has a similar problem that Wireplumber had, where if you get some syntax wrong, you put a structure in there that is not valid Lua, it just explodes. You just what
Yeah,
if you don't know Lua competently, it's very difficult to do more than just basic changes. And even then, basic changes can be complicated if you don't understand the structure the files are supposed to have, how the files link together. And yeah, I ran into that problem a lot. And I am very glad that it has gone down this route and it's considerably easier to use. So you're saying Lua
yeah,
is still used. That is still used in we said like what part was that still being used for? With the scripting part. So is that for like
scripting
policies?
part. Yeah, yeah, yeah.
Mhm.
So basically, the entire logic about what to do when events happen is
Mm.
written in Lua. Wireplumber is all events based. So when, let's say, a new application connects, you basically get an event that the new client is there, and then when this client creates a node and ports, you get events about those objects popping up. And what we have there in the scripts is we have event handlers where we can define exactly which event they handle, and then there is code in Lua that will take action based on that event.
Mhm.
And nowadays we have also this hooks system where basically we can have multiple chunks of Lua code in different files that react to the same event. And we can order them. We can say this runs before that one and that runs after that one, basically just like systemd units that have to depend to one another.
Mhm.
And we yeah, when an event happens, we take all the hooks that react to that event, we order them, and then we execute each one in order, and we try to get through all of that before we execute the next one. And that's the way that it actually works under the hood.
Mhm.
That's how we make decisions about what needs to happen and then taking actions.
So when we are talking about configuring Wireplumber, there are the like simple things that I think a lot of people kind of know about, like renaming your devices. As an example, I have Starship Matisse HD audio controller analog stereo, which is a very useful name for my 3.5mm jack. Or my mixer board here, the MGXU analog stereo. Or my favorite one, Navi 2123 HDMI DP audio controller digital, which again, that would be my HDMI port. Now, most people kind of know that you can rename devices, you can disable devices you just don't want to see. So, as an example, I would usually have my HDMI port disabled because I never listen to audio through my monitor. I will either use my speakers or my headphones. But what are some other interesting things you can do with the Wireplumber configuration that may not be something a lot of people kind of know about?
Yeah, so well, the basic principle is, as I said, you have all of those events and you have all of those hooks. And what you can do is you can write your own hooks, basically. And if you read the documentation, if you figure out exactly the order of which other hooks run and you understand what they're doing, then you can basically put your own hook somewhere in the middle and change things as the script goes. So, for example, the example that you brought is one of them, right? If a device is creating some nodes, then you can basically go and add some Lua chunk there that basically changes the properties of that node before it gets created. So you can take the name and swap it with something else, right? This is one thing you can do. Well, it's a little bit more complicated than that for that particular use case. But there are other use cases that work exactly like that. So, for example, let's say you want to select a profile for your card with some additional logic instead of having to select it on Pavo control. You can very easily write a hook in Lua that will run just before the final apply function runs, and then in there decide if you want to keep Wireplumber's default or if you want to select something else based on your logic. Same thing with selecting default devices, same thing with linking. So if an application connects and wants to link somewhere, you can either let Wireplumber take control and link it to the default output or the defined target object that has been defined by the application, or you can write your own hook, insert it there, and have it run its own logic. Which can be handy for some use cases, like if you have things that you expect to be running a lot daily and they are not being handled the way you like. Either because it's a strange device that behaves strangely and you want to manage it in a specific way, or because you have an application that behaves strangely and you cannot really change its settings internally and you want some other logic to be applied there. These kind of things you can do easily with Lua scripts. That's the intention. And additionally, through all the Lua scripts are being loaded by the configuration file. So they are not being just loaded because they are in the directory. They are being loaded by the configuration file, which defines components. There's a section called wireplumber.components, which lists all the Lua files and all the modules. And by tweaking that, you can also disable certain hooks from being loaded. So you can say, okay, I don't want this kind of logic to be applied, so you can take it off. And then you have the rest of the scripts running without that one being loaded. So that's the basic. These are the kind of things that you can do with scripting. Now, there are limits to that. Unfortunately, we are starting to find the limits to where this can go nowadays, with some more complex use cases that we have for specific devices. And we might have to, at some point, do another version where we even break things even further. So I've started thinking about Yeah, because even if you have an event that runs all those hooks, at some point it needs to take an action. So you have a new node being added, and then you run a bunch of logic, but then you have to take an action. And then you have another node being added and you take an action. And there are a lot of cases where that action depends also on the things that are going to come after. So you have to wait, you have to defer the action until you have finished loading a set of things. And we currently do that with the linking policy. So if we see that a new node is being added, we are expecting that maybe more nodes will be added. So we wait, we defer that action to later when the event loop is idle. But we're seeing more and more cases that this kind of separation is needed. And yeah, I'm starting to think that maybe we need to find a more generic way to separate actions from decisions. So take a decision here, put it in a queue, and then apply the action later. And if a decision that comes later has to modify that action, take it off, replace it with another action, then we could also be doing that. Yeah, complex stuff, but it's what makes things work. We need to have a way to make informed decisions about what we expect, the graph to be like. Yeah, it's not easy at all.
Even though you say it's not easy, we're at a state now where, at least to the average user, things are kind of transparent. And I think that's a good state to be in, where unless you want to get like into the real technical weeds, I think we're at a point where the transition over to Pipewire and Wireplumber has been like, it's at a point where it's smooth. Because I was there at the like early start where Wireplumber was not recommended yet, where Wireplumber was just barely becoming a thing that people were talking about. And I remember it was there was some rough edges at the time. There were definitely some rough edges. And at least now, I have not had any major issues for I would honestly say quite a long time, a couple of years at this point. And I would imagine that most people are probably in a similar situation. And any of the problems they do have are likely coming from some other part of the stack. Like Bluetooth is Bluetooth. Bluetooth is, especially if you're in an area that has a lot of radio signals, right? Like you're gonna have problems.
Yeah, well, it's working though. Bluetooth is one of the things that I'm proud of in Pipewire, that we have made it actually work for people instead of having them to fiddle with settings and whatever, and not having all the codecs. Like in Pulse Audio, it wasn't the case that these things would work out of the box. And with Pipewire, if you have interference, yeah, maybe that's a problem. But if you're in most cases, people just don't have any problem with Bluetooth. It will just work with any device, with any codec. It's just really good to have that working. And we are expanding. We are adding more features. So we are working on LE audio support, which is the new Bluetooth standard for audio. And there are some headsets that are starting to support it, and we have support in Pipewire for it already. Like before even the devices are out, we had support for it. I'm really proud of that kind of proactiveness in that area. But yeah, there can be cases where like people have problems if they have strange setups, or if they have I don't know, things like interference, things like just something that's not standard, and they're trying to fiddle with it, right? And some people are like that by default. Like they install Pipewire and they don't let it work as it is supposed to work. They want to fiddle with it from the beginning, and they say, oh, I want to configure this and this and that, and they start touching the configuration file, and then they break things. But yeah, that's human nature. And it's good that people actually have the ability to do it, and they have the ability to to add functionality as well, to do more crazy things.
Well, being in the position you are, where you actually are working through reports that people are making and all of this stuff, how have you found sort of the, I guess, reception of Wireplumber change? Because I'm assuming early on you were getting a lot of basic issues that were coming along where, oh, this obvious thing is broken, this is broken. But as the years have gone on, how have you found that things have changed? Do you feel that people are generally finding weirder, more obscure bugs as opposed to things that should have been there from the start?
Well, the first observation that I can make is that we have less and less reports about things being broken or,
Mhm.
problematic. Of course, we still have some reports,
Sure.
and most of the time it's not easy to go through them and actually fix them. Like I actually don't have a lot of time to be able to make meaningful like changes most of the time. Like, but yeah, for some of the cases, like we can look into them and try to go through. Thankfully, we have contributors who are looking at things and they provide the patches and everything. Anyway, when we I would say that the reports that we are getting today are, yeah, they're a bit more strange setups, I guess,
Mhm.
or they are things that we already know they are problematic, and
Mhm.
people come up with like people report them because they are still struggling with certain things.
Mhm.
These can be coming also from different hardware, different devices being used. Um, I know we're not doing a great job at handling um, UCM devices, for example. UCM being the ALSA use case manager,
Mhm.
which is the new way, the modern way of describing devices
Mhm.
with. So ALSA has this thing where, as I was saying, where in the beginning of this conversation, it basically exposes devices in a way that you don't see what they are, we don't understand what they are. And
Mhm.
Pipewire tries to make up better user-friendly descriptions and separate the different inputs and outputs. But a lot of the time, it cannot do that without having some context of
Mhm.
what the device is, right? So it needs a little bit of context, and that context is provided in a configuration file, which in the past we were using this configuration format that came from Pulse Audio,
Mhm.
and in Pipewire it's called ACP. It's ALSA card profile, and that uses Pulse Audio logic, so it creates devices in the same way as Pulse Audio was creating them. And we are transitioning to UCM nowadays, where it's a standard way of describing devices directly in ALSA. So there's configuration files that ship with the ALSA libraries, and those configuration files describe the devices that we need to create on our side. And they are very different from what the Pulse Audio logic was. So, for
Mhm.
example, in the Pulse Audio logic, we had a profile where would be analog output and input. And then if you wanted to switch to HDMI, you had to select another profile, which is HDMI.
Mhm.
And if you had multiple HDMI ports, you would select HDMI 1, HDMI 2, and every one of them was a different profile. And for every profile, the nodes of the other profile would go away. So if you were switching from analog to HDMI, the analog nodes would go away, and then you would have HDMI, right? So
Mhm.
you would only have one input output at a time. With UCM, it's not the case. We create all of them at the same time if they are not mutually exclusive on the hardware level.
Mhm.
And it's usually the case that HDMI and analog have nothing to do with each other, so that you can have them running in parallel and output to both. But depending on the device, you can have all sorts of problems there with that representation. And sometimes we come up with profiles to mutually exclude devices,
Mhm.
but they are obscure. They have obscure names. They have the switching also takes away the nodes that you had before and recreates them. Sometimes, like you have an analog output and you switch profile, and the analog output is destroyed and then recreated exactly the same way it was before. Makes no sense, but that's how we do it nowadays. And yeah, this can lead to problems. And also other kinds of problems that I know we have is the naming, for example. Like you said it yourself, like you're frustrated about the names that you have on your devices.
Again,
and I completely agree.
If I clip this section for anyone who is unaware of the device I'm talking about, open up Pulse Mixer or Pavu Control, you see what I mean. Starship Matisse HD audio controller analog stereo. That's just one of my inputs. We can go to one of my outputs. Inputs are just as actually inputs are worse, because then you have monitor of Starship Matisse HD controller, HD audio controller stereo, and I got a bunch of these. Yeah, they're not super useful names in a lot of cases.
Yeah, they're very strange names. And it's not easy to fix either, because different classes of devices have different ways of representing their names. And even on the same class of device, sometimes you find discrepancies. Like USB cards typically have, like, some will put the model in the description, some will put it in the name, some will put it somewhere else. And you have to scramble to find which one is the model and which one is the, company name and which one is what. There is no way to figure that out programmatically. Yeah, well, actually, one of the ideas I had there was, well, I don't know, what if we could run a very small language model to actually parse that information and get the context of what is what? That would be awesome. But yeah, I have no idea how feasible that is, or if it's something that we can pull off.
It's an interesting experiment. I would like to see the results of that.
It is. Yeah, I'm also interested to investigate that. But yeah, it's a problem. Like there is no solution. There is no good solution, because the manufacturers of those devices don't follow a spec, basically.
Yeah. I'm sure you've thought about this question a lot longer than I have. I don't think I can provide any insight into a better way to handle it.
Yeah, like me neither. I'm just coming up with crazy ideas just to see what we can possibly do about it. Yeah.
So what is your background look like? How did you find yourself at Collabora? How did you find yourself working on audio stuff? Like what brought you here?
Good question. So yeah, I started I guess I started back in school. I guess I was just curious with writing programs. I found myself trying my first Linux distribution out of a DVD that came with a magazine, and it was saying Mandrake Linux something, and I was like, okay, what's that? That's some kind of software. Like I have to install it, because I was always a curious child. I was looking at, especially when it comes to computers, I was downloading a lot of software on Windows at the time, and I was testing it. And I just wanted to learn anything new that was out there. So I installed that. Didn't understand how initially, but yeah, I installed that. I broke my Windows setup, obviously. And I had to learn how to get through that and how to use it. And I learned quite fast, actually. I was able to get back on the internet with Mandrake Linux and find my way there. And then I realized that, this environment is open source. That was a revolution to me. I didn't know that this was a thing, right? And what open source allowed me was to be able to write my own code and contribute there and change things and make them the way I liked. So I got into programming basically by playing with a software called Qt Designer. That was the Qt, the Qt toolkit designer that was allowing me to write user interfaces, and it had a side thing where you could connect actions from the buttons to code, and that code was written in C++. So I started learning C++ through C. Initially, I learned C. I downloaded a book. I learned C, and then I started writing C in the C++ functions and started discovering what C++ is like. Right, and I was finding the differences, and all of that was in school. Right, I was still in high school. That led me to computer science studies at the University of Crete. And while I was studying there, I was still investigating this whole Linux environment thing, and I started contributing to KDE because that came naturally after learning Qt. I was contributing to KDE, initially looking at bug fixes. So I was basically the QA guy. I was going through tickets, and I was trying to reproduce them and give feedback to users. But occasionally I would see something that looked like I could fix easily. So I started writing small patches as well and figuring out how I can make changes. And that led me in a Google Summer of Code project in 2009, where basically one of the guys that I was interacting with a lot on IRC at the time in the KDE community, he brought that idea to me. And the idea was to write a video call client for KDE. At the time, we were doing, it was a huge thing to do telepathy. Telepathy was a framework to unify all the instant.
Oh. Wait, did he disconnect? Did I disconnect? What happened here? Oh, lovely. Hello.
Yeah, it came back. Okay.
Okay, this is gonna be two of me for a moment. I don't
Sorry
know.
about that.
Yeah. So you're talking about framework telepathy.
Yeah. So telepathy was the thing that was going to unify the protocols, the instant messaging protocols, and yeah, there were backend programs that were talking to the various protocols, and at the front end we had a chat interface, and then we were trying to write also a video call interface to be able to do video calls with without using browsers. Let's say I think using browsers at the time wasn't that common, to be honest. It was more that you had an application running on your desktop that was doing the call. Anyway, the idea was to write a video call client, and I started working on that. I took the Google Summer of Code project, and basically that taught me how to use GStreamer, which is a multimedia framework that I was using for actually doing the video processing and audio processing and streaming. And I'm really sorry. It's there's a HomePod in the corner that I never use, but for some reason it decided to speak up right now.
It's been fine throughout the entire episode, just now. Okay, sure.
Yeah, so I learned GStreamer out of that.
Yes.
And that's how I got into Collabora as well, because I knew GStreamer, and actually the guy that was mentoring me was working for Collabora at the time. And there was, I guess I was lucky. I was there in a moment where Collabora was trying to expand and they were hiring lots of people. So yeah, they hired me. And well, shortly afterwards, like a year afterwards, telepathy pretty much died because Nokia died. If you know the story of Nokia at the time, it was that they were building a phone, they were building a platform, and that was using telepathy, was using a lot of open source stuff, but things were not working for them internally. And at some point, they sold themselves to Microsoft, and Microsoft killed everything, and they said, okay, we're going to replace it with Windows Phone, which also didn't work.
Yeah.
So so telepathy died, and I had nothing else to work on at the time in Collabora other than GStreamer. And so I dived more into that. And I was, like I said, from a small age, I was very curious about things. So when there was something that I didn't know well enough, I was curious to learn, whatever it was thrown in front of me. So GStreamer was thrown in front of me, basically, and I was seeing an opportunity to work there and make real money out of doing open source software. And it was just exciting. So I learned how to get around with GStreamer, and that's how I got into the multimedia team at Collabora. And that's also how I got into audio. Of course, I did video. I still sometimes do video stuff as well with GStreamer, but I was hired in 2011, and I was doing GStreamer all of that time. But in 2018, as I got into the automotive grade Linux project, I started looking into Pipewire, and that led me into the whole Pipewire and audio work that I'm doing today.
Okay. Yeah, that was. I like that.
Yeah.
That was a good. That was a good answer. Yeah.
Yeah, it's basically my life story in a like small description, I guess.
So you've kind of just been involved in some way with it for kind of a long time now, and I guess, yeah, now Wireplumber. I guess how does it feel that Wireplumber is basically it's basically the standard session manager across every distro at this point. I'm sure there's still some random one out there that's using media session, and you have the distros which will always be doing whatever they're doing. But across, Fedora, Ubuntu, Arch Linux, pretty much everywhere, it's Wireplumber.
Yeah. How does it feel? I guess it feels good to know that people use your software. But at the same time, I'm never satisfied with what we have. I think that it could be better. It could be much improved. And even though it's being used, a lot of people just don't know it exists. Like, they use it in the background. They don't really care about it, right? And also, the people who know it exists, sometimes they don't know how to configure it, how to modify it. So that kind of defeats the purpose of it, because it's supposed to be something that is easily configurable and easily allows people to change things. And I see that not only on the desktop, but also on devices. So occasionally I interact with customers that have already adopted Pipewire and Wireplumber in their setups, and they are just doing everything wrong, right? They don't modify Wireplumber, they don't write scripts, they basically build their own logic on top of it, or they do like other things, like using Pulse Audio APIs or Jack APIs to modify things on top, which basically sidekicks Wireplumber into just being the default that it is on desktops. Yeah, so yeah, I guess it feels, as I said, it feels good to have the software used, but I would like to. I'm never resting that it's a good software or it's a good thing to have. Like, it can be improved, it can be better. Yeah.
All right. If people want to get involved in Wireplumber and all this, what's the best way to go and do so?
Well, the code is over there. You can just download it. You can look at the documentation. We have a documentation website where everything is laid out for you. Well, if there is anything that you don't like, people don't understand, there is always the contact channel through IRC or Matrix. Like I use Matrix myself, but we have an IRC bridge. The channel is the Pipewire channel, so Pipewire matrix.org or hashtag Pipewire in the, I don't remember which network. I think it's OFTC, but yeah, it's been so long that we haven't touched the bridge. Anyway, yeah, you can get in touch with us there if you need questions answered or if you need further like ways to talk to me directly or some of the other contributors. And obviously the code is on a GitLab instance on gitlab-freedesktop.org, so you can submit merge requests there. That's the best way to submit code, submit a merge request. Or you can submit issues there as well. If you are not confident on writing the code yourself, you can submit an issue. We can look into it. And you can also file issues for support. I'm not guaranteeing that it will be answered. Like if we have lots of questions, but a lot of people do actually open tickets for support, and they say, "How do I do this? How do I do that?" And I try my best to answer those questions if I can, if they're really easy to answer. Yeah, that's basically it. That's the communication.
Did we disconnect? You
I
doing
don't
so?
think so.
Oh,
Hello?
yes. Okay, we're back now. Disconnect for a moment.
Yeah, I wasn't really saying anything. I was saying, yeah, it's
Okay.
GitLab is there. You go to GitLab, you submit merge requests. The code is there, documentation is there. That's about it. And the Matrix channel.
Awesome. It has been a pleasure talking to you. I think this was a really good episode. Do you think there's anything? Do you think there's anything we sort of missed that is worth touching on?
Good question.
Think back over the last 2 hours of talking.
I don't think so. I guess not. I think we've touched pretty much everything about Pipewire, Wireplumber, my backstory. Yeah, I can't think of anything.
Okay. Wireplumber docs, where are those located? Just for anyone who wants to go configure it.
So the link is a bit obscure, but basically you can go to gitlab-freedesktop.org, go to the Wireplumber project, and on the README file, which shows up on the main page, there's a link. There's a link to click and for the documentation.
Pipewire.pages.freedesktop.org. I feel like somebody needs to maybe work on some better URLs.
Yeah, I actually have a domain. I have both the domain, wireplumber.org, but I haven't been able to connect it. I think I need support from sysadmins there. So that's something.
Okay.
That's something on my to-do list to actually get it to work.
Just if you can't do that, just set up a HTML redirect. That's good enough.
Yeah, that should work, but yeah.
Yeah. Is there any other links you want to mention? I noticed you had you don't post a ton, but you do have your own personal site with some blog posts on it.
Yeah, my personal website is gkiatelier.gr. I can send you the link afterwards so you can put it somewhere. And of course, there is the Pipewire website, Pipewire documentation as well, that is also very relevant. Something that maybe we haven't mentioned enough is that, yeah, a lot of people get confused about what is the borderline between Pipewire and Wireplumber, and especially because the device plugins are maintained in the Pipewire project, but they are being loaded by Wireplumber, so they are being in two places at the same time. If you're looking at, let's say, Bluetooth options, you have to go to the Pipewire documentation to find what those options are, but then you have to write them in the Wireplumber configuration file, which is a bit strange for people. I hope we can do a better job at clarifying that and describing that in the future. But that's how it is nowadays. And if you are looking for documentation, sometimes it doesn't suffice to look at one place. You have to go to the other place as well to find what the options are and be able to write them. And also, when you are reporting bugs, it's also unclear at this point which component. Is it the Wireplumber or is it Pipewire? Especially when it comes to device management, right? Because you might think that, for example, audio card profiles are being generated by Wireplumber because Wireplumber conceptually is the thing that manages your device. But in fact, it doesn't do anything besides loading a Pipewire plugin. So the Pipewire plugin is what actually implements that logic. And the ticket actually goes to Pipewire in that case. But of course, yeah, it's hard for people to figure that out and know that from the beginning. So if you have an issue, just file it to the best project that you have thought of is relevant, and then we can move it around.
Okay, awesome. Nothing else you want to mention?
No, I'm good.
Okay. As I said before, pleasure to have you on. This was really good episode, and I'm glad that some random person who joined my Patreon just decided to connect us together.
Yeah, I'm glad as well. I'm glad as well, and thank you for having me on the podcast.
Yeah, absolute pleasure. Okay, so I'll do my outro and then we'll sign off. So my main channel is Brody Robertson. I do Linux videos there 6-ish days a week. Sometimes I stream there as well. Probably gonna do another Cosmic stream at some point when they have another beta. I don't know. I'll think of other streams to do there as well. I've got the gaming channel that is Brody on Games. Right now I'm playing through Yakuza 6 and Silksong. And if you're watching the video version of this, you can find the audio version on basically every podcast platform. Just search Tech Over Tea and you will find it. And if you want to find the video, it is on YouTube, Tech Over Tea. How do you want to sign us off? What do you want to say?
I don't know. Take care.
This is my favorite part. I never tell anyone they're doing this. Nothing?
Yeah, well, yeah, take care. Happy using Pipewire, I don't know, something like that. Have fun with Pipewire and Wireplumber.
Okay, that works.